Hello, Camdia friends. I hope everybody is well, is happy and healthy. Thanks so much for tuning in tonight. Hey, how's it going, Preeti?
Hey Adam, how are
Yeah,
you?
yes, doing well, doing well. Really grateful for you stepping up tonight. I thought I'd put a tie on. I thought let's make it a little bit more professional. So tie and a monkey suit it is. As I said, really grateful for you stepping up tonight to save the event. So yeah, ready when you are.
I'm happy to be here. Thank you, Adam, for that introduction. And just going to share my screen quickly. Okay, does it look good?
Yes, perfect. Ready when you are. Looks great.
Okay, awesome. So, hello everyone. I'm very excited to be here and talk to all of you today. I will spend some time sharing my experience on what it takes for ML to be successful in a business. And at the end of it, you should have a reference for either setting up ML or maybe improving your ML efforts. So, a little about me. I'm a data science manager at Wattpad. I am passionate about taking data from being just a nice to have to a must have. I worked as a systems engineer for a number of years and then made the switch to data. And during the pandemic, I picked up some new hobbies. So now I'm into DIYs and I love making soaps and natural dyes. So before we get into the content, let's set up a baseline, a common understanding of some terms and ideas. So we have machine learning and then we have success. So let's unpack these two terms a bit more. So what is machine learning? What I have here is a definition from Oxford Dictionary, and I will pause for a moment so you can read what it says. So that's a lot, but the important aspect here is that ML really is an instrument. It's a tool and it's a means to an end. So there is an objective, there is a problem that you need to solve, and ML is a tool that helps meet that objective. We also need to make a distinction between ML for business and then ML done as part of R&D. So in R&D, some things that we care about are things like how new is the model, or how innovative it is, or how much of an improvement it is over an older model. Whereas in business, we are concerned with different things. So, what we care about is how useful is the model, or what is its impact on a business goal, what is its return on investment, or what are costs and benefits associated with building a model and then maintaining it. So let's take an example. So consider a model that is for ad targeting for subscribers. So subscribers here would be users that pay. So from a research perspective, this is important, and that is because there are behavioral patterns in subscribers that are different from free users, and how they use the product is quite different. So there is a lot of interesting data. But if the business decides that subscribers, that is the paying users, will no longer see any ads, then the model is no longer serving any business decisions. So, although it's a useful model, it's not really creating any business value. So, that's about ML. What about success? How do we define success for an ML model? So if it is successful, then there is adoption of that ML model. And that means two things. First, the model deployed has use value. So maybe it is powering a product feature, or there are business decisions being made based on the outputs from this model. And second, it also creates impact. So there are business goals or objectives that can be attributed to this model. Another thing to discuss before we get into the thick of it, there are two common modes that ML data teams operate in. So, one, the product or business identifies an ML use case, and then they engage the data team to build this model out. And when this happens, there is generally a good understanding of the impact that this model will create and how that impact will be measured. The second mode is what I would like to call the unsold ML use case. So here, it's the data team that drives ML development. So they identify the use cases, and they are in a good position to do that because they closely partner with product and business. So what they do is they come up with the use cases, then they prototype models for this, and then sell these models to the stakeholders. Now, with this background, let's look at the pillars for ML adoption. From my experience, there are 4 pillars that are important. So one is technology and infrastructure. The second one is product or business readiness. And then you have people and processes. So looking at this, you would say, well, this covers all the aspects in an org. And yes, you are right about that. And that is because ML systems are complex. You must have seen this diagram. It's quite popular in the data community. It's from a paper on hidden technical debt. And as you can see here, the ML code block, which is right in the middle, that is a small portion of a much larger system. So there are several components in our typical ML system. So let's look at each pillar in some detail. The first pillar, technology and infrastructure. Now, this encompasses everything that a data scientist would do to build a model. So there are 2 parts to this. One is training and then inferencing. When it comes to training, of course, you have things like testing, validation, basically experimenting on building a good model. So here you could try different libraries, different frameworks. You could build new features, feature pipelines. You could evaluate data quality and then use techniques to improve the quality. You could also test different model parameters with the objective that you produce an optimal ML solution or an ML model. And then there is inferencing. So again, inferencing could be on a prototype. And this is a prototype that you are sharing with the internal stakeholders so they know how the model works. Or you could do inferencing on a productionized model. So that is when a model is exposed to the external users outside of your org. And some things to consider here for inferencing would be how scalable your infrastructure is. So does it meet all the SLAs that you have set up for model serving? Then if it is capable of doing distributed data processing, so are you using the right framework for that? You would also consider things like, do you need batch or real-time inferencing, and do you have the right tooling for that? So this is not really an exhaustive list. There are many more things that data scientists and MLEs do, but this pillar covers all the technical aspects of building and serving a model. So looking at the 2 modes of operations for the data teams. So one was product identifies the ML use case, and then data team identifies the ML use case. This pillar is agnostic to the 2 modes. So whether the ML use case comes from product or it was conceived by the data team, this pillar looks the same for both the modes. The next pillar is product and business readiness. So what does it mean? So with any given ML model, there are product design and code changes required to integrate that ML solution. So to take an example, if you have built a new recommendation engine, then one of the simplest changes you would need is how to display those recommendations to the users. So implementing these changes to integrate that ML solution is what product readiness means. And what determines that? So there are things like, is a product and engineering, do they have enough capacity? Do they have time? And do they have all the right resources to implement these changes? It's also possible that you may require features that complement the ML model. And these also need to be designed and implemented. So taking the same example again, there's a recommendation engine. Maybe what you want to do is provide a way for users to add these recommendations to either their library or to their cart. So this also needs to be built and designed and then built and implemented. So all of this together tells us how ready product or business is, and that is what this pillar is about. So coming back to the two operating modes, it turns out that this pillar is also agnostic to the two modes. So the things that we just saw, product or business and engineering will need to do all of that, irrespective of how the ML use case was conceived. The next pillar is people. So apart from the usual suspects in ML, so you have data scientists, you have MLEs, there is one other role that is quite important, and that is that of a product manager. Now, people use different titles. Some call themselves data product manager, then you have ML product manager, but let's just call them product manager for now. So product managers or PMs in general represent customers. In the case of ML, they represent product and business. And they have a role to play in all the stages of ML development. So before development starts, they identify and prioritize the right problem to solve. So typically, a business has many different problems they are working on, and not all of them are really aligned with their immediate or long-term goals. So product managers help identifying the right problem. Then during ML development, they keep track of changing business needs. So again, businesses are agile, their needs frequently change, and PMs help keep track of those changes. They also help in designing business metrics. So for any model, you have a model metrics, which covers performance, like the technical performance of a model. And then you have business metrics. So these are metrics that a model impacts. So PMs help design these metrics. They also bring user feedback from stakeholders. And this is to ensure that model is always aligned with the expectations. They also engage engineering as and when required to build these other features out. And after a model is developed, they decide what is the best time to deploy this model and expose it to the end users. They also look into use case expansion. So maybe it's possible that by the time your model is built, there may be additional use cases that this model supports. So they look into that. They also educate stakeholders on the solution. So what does the model do? What does it not do? And how should it be used or not be used? And they also continue to engage engineering to build these other features out. So coming back to the two operating modes, how does the role of a PM change? So their role looks different based on what mode you're operating in. So for the first one, where a product identifies the ML use case, they do play a significant role and they are involved in every stage of ML. In the second scenario, which is the unsold ML use case, it is mostly a data team initiative. So here, data team assumes the role of a product manager. They step into their shoes to anticipate, design, and build this model out. So once it is built, business then decides the fate and shape of this model based on the criteria that we earlier saw. The last pillar is processes. So like we all know, ML is a multi-team activity. So that means that there should be an exchange and alignment between different data teams. So data teams could be your data science team, data engineering, ML ops, and so on. And you also need alignment between data and product teams. And how can this be achieved? Well, by setting up good processes and systems. Setting up processes will help with questions like who monitors the models, who maintains them, or who's responsible for any retraining that is required. Or questions like how is system level performance monitored and what happens when something goes wrong, who is responsible for fixing it. They also help us define how the handover happens from a model being ready to handing it over to the ML ops team. So these are the kind of things that processes help with. And when it comes to product, what are the channels for feedback, and what kind of feedback is most beneficial in building a good ML model. So when it is product or business identified ML use case, models always get deployed, and that is because there is a push from the business. But if there are no processes in place, the deployment solutions may not be standardized. They may not really consider the long-term view in interest of building something quickly. In the second case, where it is the unsold ML use case, setting up good processes becomes even more important, because in their absence, people will be dissuaded from productionizing the model. Another good thing about processes, the right processes, is that they will ensure that there are standards in serving patterns and ML ops. So bringing it all together, summarizing the first pillar, technology and infrastructure, as a good prototype. The second, product readiness, as product and engineering maturity. And then people as data scientists, MLEs, product managers. And the last pillar as mature ML ops. All of these together determine how successful an ML model is. So what are some signs of a broken system? How do you know when something is amiss? So I have a few examples here. The first one is maybe there is model drift, but the data team doesn't get to know about it. It's the business that brings it to the data team. And that could be a symptom of not having ML ops for monitoring and maintenance. It could also be that incorrect model metrics are being tracked, and that is why the data team doesn't know about the drift. It's possible that there are models developed by the data team, but they only exist as prototypes, and they are never productionized. This could be because there is no product manager to bridge between data and business. It's also possible that the data team is not aligned with the business objectives, which is why the models developed have no business value, so to speak, and that is why they are not being productionized. Or there may be a gap in ML deployment skills and tools. The third example here is you generally train on a small data set, and once everything works well, you expand the data set. But maybe when you do this, things don't work quite well, and that may be because your infrastructure does not scale well. Maybe you are using on-premise, but what you really need is something in the cloud. It's also possible that you are using incorrect data or training libraries. And the last example here is maybe the model is in production, but no one really knows what its impact is on business. So this could be because the business metrics that the model impacts haven't been established, not been fleshed out. It's also possible that an attribution model that ties ML back to the business goals, that hasn't been worked on. So that was my experience on successful machine learning. I would love to hear from you on what your experience has been. And you could get in touch with me on LinkedIn or Medium, or set up a call with me. And there is a link to a survey here, and I would love to hear your feedback.